So in this lesson, we're going to talk about something called equivalent fractions. This word equivalent is going to be used a lot over the course of the school year. Equivalent fractions, equivalent ratios, equivalent expressions, on and on and on. And what you need to know about this word equivalent is that it means equal. Okay, equivalent is just a fancy schmancy word for equal. And so in this lesson, your goal is I can make equivalent fractions. So equivalent fractions are not too difficult. This is a pretty short lesson. Equivalent fractions are fractions that actually look different, but they have the same value. It's a little bit like simplifying or reducing fractions, except that instead of going smaller, we can also go bigger in order to make an equivalent fraction. But the key word here is that equivalent means equal. All right, so you can always make the numerator and the denominator of a fraction bigger in order to make an equivalent fraction. So let me give you an example here. Here I have the fraction 2 over 4, okay? Focus in on this first box right here. The way I make it bigger is I multiply the top and the bottom by any number in the world that I want to. The key is that it has to be the same exact number. So I'm going to multiply the top by 2 and the bottom by 2. 2 times 2 is 4. 4 times 2 is 8. My new equivalent fraction is 4 over 8. Now what makes this important? 4 over 8 has the exact same value as 2 over 4. Look at this second box over here. Again, I'm starting with 2 over 4. I'm going to now multiply the top and the bottom by 3. Why 3? I don't know. I pick 3. You can pick whatever number you want. And I'll show you examples of that in a little while. So 2 times 3 is 6. 4 times 3 is 12. What's interesting about 6 over 12? It has the same exact value as 2 over 4. Now I'm on the third box over here. This time I decided I'm going to multiply by 5s. Why 5s? It's up to you. I just decided to do 5s. 2 times 5 is 10. 4 times 5 is 20. 10 over 20 has the exact same value as 2 over 4. Now I'm going to multiply by 10s. 2 times 10 is 20. 4 times 10 is 40. But here's the thing, guys. 20 over 40, 10 over 20, and 6 over 12, and 4 over 8 all have the exact same value as 2 over 4. All I did is I made the numerator and the denominator bigger, but I made them bigger by multiplying them by the same number, and that's how the value stays the same. So remember, you can always make it bigger, but here's the key. Sometimes you can make the numerator and denominator smaller. Not all the time. Sometimes you can. In this case, 2 over 4, and this is where we're going to go back to simplifying, it can be simplified by the GCF of 2, by dividing by 2. And I'm going to get 1/2. 2 divided by 2 is 1. 4 divided by 2 is 2. So you can always go bigger, but sometimes you can go smaller. And that is literally it for equivalent fractions. It's all about making them bigger or smaller. So let's look at some examples here. So 4 over 6, I want 2 examples of bigger and 1 of smaller. And so I'm going to decide to multiply times 2 and by 5 over here. So 4 times 2 is 8. 6 times 2 is 12. I just made an equivalent fraction. Over here, I'm going to multiply by 5. 4 times 5 is 20. 6 times 5 is 30. I just made an equivalent fraction. 20 over 30 and 8 over 12 have the exact same value as 4 over 6. But now I want us to go smaller. And so in order to go smaller, I need to find the GCF. And so I'm going to make a quick little factor tree here. I have 2 2's. And then with 6, I have a 2 and a 3. So it looks like my matches are 2's. So I'm going to divide by 2. So 4, and so I'm going to put it up here, divide by 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. And I just, again, made an equivalent fraction. All right, let's look at 9 over 13. So this time I think I'm going to do times 3 and times 10. And you may be thinking, where is this lady pulling these numbers from? I get to pick any number I want. If you want to multiply them all by 1,985, that's fine. I probably wouldn't recommend it because there's a lot more room for error, but as long as you're multiplying the top and the bottom by the exact same number, you can do it any way you want. All right, so 3 times 3 is 9. And 9 times 3 is 27. This is an equivalent fraction. Now I'm going to multiply by 10. 10 times 3 is 30. 9 times 10 is 90. 30 over 90 and 9 over 27 are equivalent fractions to 3 over 9. But now I want to go smaller, so I need to make myself a little factor tree. 3 is prime, so it stays at 3. And it looks like my GCF is 3. So instead of multiplying, this time I'm going to divide by 3. So 3 divided by 3 is 1, 9 divided by 3 is 3, and that is the equivalent fraction. All right, down here, I think this time I'm going to do times 2 and times 3. Now, some people might be thinking, why don't you just do times 1? Well, anything times 1 is itself. And so if you multiply it times 1, you're going to end up with the exact same fraction, which is not an equivalent fraction. All right, so 4 times 2 is 8. 12 times 2 is 24. Now I'm going to multiply by 3's. 4 times 3 is 12. And 12 times 3 is 36. So again, these two are now equivalent fractions of this guy over here. But now I want a smaller one. And so real quickly, I'm going to find my GCF. So I have 2 and 2. And over here with 12, I have 2 and 6, 2 and 3. And it looks like I have two 2's that are matches. 2 times 2 is 4. So we're going to end up dividing by 4. Okay, so 4 divided by 4 is 1, and 12 divided by 4 is 3. And so again, I've come up with an equivalent fraction. Now, you won't always have the option to make them smaller. I happen to put fractions up here that I knew could be made smaller. That won't always be the case. And so if I ask you for an equivalent fraction, you can go smaller if you're able to, but don't be afraid to go bigger as well. All right, let's go ahead and try these guys real quick. So over here, I'm going to multiply times 2, over here by 5. So 2 times 2 is 4, 8 times 2 is 16. Now I'm going to multiply by 5. 2 times 5 is 10, 8 times 5 is 40. This time I want to go smaller though. My GCF here, make my factor tree real quick. And it looks like my GCF is going to be 2, so I'm going to divide by 2. 2 divided by 2 is 1, 8 divided by 2 is 4. I'm going to pick up the speed here a little bit. So here I'm going to go bigger by 3's, and here I'm going to go bigger by 10's. So 7 times 3 is 21, 9 times 3 is 27. 7 times 10 is 70, 9 times 10 is 90. Now I want to go smaller. So the thing with 7 is that it is a prime number, and 9 breaks up into 3 and 3. Now, here's our problem. There are absolutely no factors that match each other, and so it is impossible for me to go smaller because it's impossible for me to make that fraction any smaller, okay? Let's see. Here I'm going to go, oops, wrong color. Oops, let's try that again. Okay, so here I'm going to go times 4, and here I'm going to go times 100. Okay, 3 times 4 is 12, 5 times 4 is 20. 3 times 100 is 300, and 5 times 100 is 500. Again, I can go as big as I want to go, I just have to be careful when I calculate my numbers. Now, when I make a factor tree to go smaller for 3 and 5, I'm not going to end up with any factors that match because they're both prime numbers. And so I cannot go smaller on that fraction. All right, now what I want you to do here is I want you to try, these two. Now keep in mind I'm asking you to do two different things here, so I'm re-looping in from the last lesson. At the top, I want you to put it in the simplest form, meaning I want you to simplify, I want you to reduce as small as it can go. That's from the last lesson. And on the bottom, I want you to find an equivalent fraction. You can choose. Do you want to go bigger or do you want to go smaller, and by how much? And we'll talk about the answers in just a second. All right, if you're not done, go ahead and pause the video so you can finish. So up here at the top, I asked you to simplify. I asked you to reduce. So I found the GCFs here just so that you can reference them. So 12 over 22 comes out to 6 over 11 with a GCF of 2. 4 over 20 comes out to 1 over 5 with a GCF of 4. 55 over 88 comes out to 5 over 8 with a GCF of 11. Now down here, our answers are going to vary a lot with the equivalent fractions because you might have decided to go much bigger than me, much smaller than me, etc., etc. 1 over 3, I kept it simple and I multiplied the top and the bottom times 2. I came up with 2 over 6. 7 over 35, I also kept it pretty simple. I multiplied by 2. Now, you could have gone smaller on 7 over 35 and gotten 1 over 7. But I ended up with 14 over 70. And for 3 over 8, I decided to multiply the top and the bottom by 10, so I got 30 over 80. All right, that is the end of equivalent fractions. Keep in mind, if you're going to go bigger, you need to go bigger equally on the top and the bottom. Let me know if you have any questions.